Happy days. Okay, so today I'm going to be talking about Rust and why we as JavaScript and web developers should care. My name is Paul McBride. I work as a JavaScript developer myself here in Belfast for a little startup called Nice. And I also run wecodeandI.com, which is a job board for developers like you and I. So before we dive into what Rust is and all that kind of stuff, I want to tell you a little bit about sort of where I'm coming from it, the sort of expectations that we should have for this talk and that sort of stuff. So I have never written Rust professionally. I've only ever played with it for little toy side projects and that kind of stuff, just out of interest. It's not something that I've ever been paid to write or ever released to production. Also, this is a lightning talk, so I'm probably not going to get a whole lot of time to actually teach you how to write Rust. This is more going to be showing you like what Rust is good for and why you would use it and why you wouldn't. So what is Rust? It's a pretty good question. And if we take a look at the strapline on their website, it says that Rust is a language empowering everyone to build reliable and efficient software. That sounds great, but it also doesn't give us a huge amount of information, which is not surprising considering it's a single sentence. So if I was to describe Rust myself, I'd say Rust helps developers to write software that's memory efficient. It's kind of a modern replacement for languages like C++ and C, with a focus on code safety and concise syntax. It's a little bit different from JavaScript, whereas JavaScript, whenever it's running, we'll try and find variables and objects and stuff that aren't being used anymore and release those from memory. This is called garbage collection. Rust does not have a garbage collector, similar to languages like C and C++, but it's way less painful. Also, as going through this talk, I will probably dunk on C and C++ a lot. And I'm doing that out of love. I don't actually write C or C++, but I know many people that do, and no one seems to have a good thing to say about it. And I've been told that writing new software in today's day and age in C or C++ is basically a crime, and that Rust is a fairly good replacement for that. So what kind of things can you actually build with Rust? If you go onto the Rust website, they have a great section that kind of, they have these books that basically teach you how to build certain types of applications whilst you're learning the language to help introduce you to certain concepts. And the first one that you typically build is a CLI tool. And there's lots of stuff, CLI tools built in Rust. Cloudflare, their CLI tool called Wrangler is built in Rust. It's a really good repo. So if you want to look at a well-structured CLI tool, go check it out. It's also really good for building web servers. Rust is an extraordinarily fast programming language. The two main frameworks for Rust for the web are called Actix and Rocket. But because it's a fairly new programming language, the frameworks are a little bit immature. So they wouldn't have the same kind of functionality that the likes of Ruby on Rails or something would. And there's still a lot of stuff where you're kind of having to do it by hand. It's also a really great language for games because it's, again, small and very fast. Anyone that's ever built a game before will know that performance is something that you run into pretty quickly, especially if you're building games for less powerful devices. And so a language that can help you use memory or processing power efficiently is a good shout. So Rust will work for that. Same with embedded devices where there isn't a lot of power or memory, for example, available. Rust is a great language where you're in control of what memory you use. So you're not relying on a garbage collector to handle that sort of stuff for you. And that applies basically to anything where reliability and correctness is essential. So if you can imagine like a pacemaker or something like that, where a memory leak would not be the kind of thing you want to ship to a pacemaker. It's not like the web where you can update it on the fly. So anything like that, where it's super important that the software, if it compiles, it works. Rust is a good fit for it. It's less great for rapid prototyping. This would not be a competitor to no code type stuff. Rust is reasonably involved when you write it. So let's take a look at who uses Rust. One of the very first companies that kind of went all in on Rust was Mozilla. So they use it in Firefox and Servo. Servo is kind of like to Firefox what V8 would be to Chrome. That's their JavaScript engine essentially, and it was entirely rewritten in Rust a few years ago. So if you use Firefox, you've got Rust running on your computer. Figma recently rewrote their multiplayer or their real-time engine in Rust. Previously, it was TypeScript, and as far as I'm aware, they started to run into the limitations performance-wise of TypeScript, because this has Figma has such a huge amount of traffic, and that real-time stuff is hard to do. I work on a similar kind of thing myself. Rust is what they used. Their engineers said that they were looking at C++, but it would have taken them far too long to get up to speed with C++, whereas Rust, the compiler, and the strict rules of the language helped nudge them into writing the kind of software they wanted. Microsoft have been investigating it as well for its memory safety. And I think they're actually working on a language themselves that kind of takes a lot of the learnings from Rust. And what I mean by memory safety is Microsoft ran a survey a few years ago where they looked at all of the most critical software bugs that it shipped in all of their software, the likes of Word and that sort of stuff. And they found that 70% of all of those like serious security vulnerabilities were caused by using memory unsafely, where a variable was left dangling or something, and it allowed people to be able to access out of scope memory and read things from memory that they shouldn't have been able to. Rust just does not allow that out of the box. You can step outside of Rust's safety by wrapping your code in an unsafe block, but there's almost no reason that you'd ever need to do that kind of thing. Cloudflare, I mentioned before, they use it for their CLI, and they also use it for their edge functions because it's small and fast, which is what you want for edge functions. And that's basically their Lambda functions, but on the edge. Discord did the same thing, went from Go to Rust. Go is also a really fast programming language, but it uses garbage collector. So they use this in Discord. They use this for their read status, so to check and tell a user whether a message has been read or not. And what they found in Rust or in Go was that the app performed fantastically, except every so often, whenever the garbage collector would start running, and it would tank the server performance because it was just eating up all the memory and processor to do this kind of memory clearance. So they moved to Rust and had a good time. All of these case studies, by the way, are available on the Rust website. So if you want to kind of dig into those and what they're doing, you should go check it out there. So I was dunking a little bit on C++ earlier, saying that most people hate it, the work with it, but that's not the case for Rust. In 2016, the Stack Overflow survey was ran, and 79% of people that wrote Rust professionally said they loved it and was voted the most loved language. That was also the case in 2017 and 2018 and 2019 and 2020 and also 2021. It's a fairly popular language by those that write it. It's got a great community too. It's a small community, as I said, though. It is not the language that it hasn't reached the sort of critical mass yet where it is used ubiquitously like JavaScript has, but it is on its way up. If you get stuck on something with Rust and you need some help, which you definitely will when you get started, and you ask on Twitter, there's a fair chance that the actual core maintainers of Rust or the Rust Foundation will reply to you and help you out. It's a really cool community. They have a really great set of guidelines about what they expect from their community members, and they do a pretty good job of enforcing that sort of stuff too. So what's it actually like to write Rust? We've seen that it's very well loved. So let's look at some of the language features then and see what people are actually saying about it and how it works. So it's a strongly typed language, which means that whenever you create a variable, you have to define the type of that variable. So whether it's a Boolean or an unsigned 32-bit integer, for example. But you don't need to be explicit with it. If the compiler is able to work this out or infer it for you, it does so. So like if you created a variable that was just a Boolean, you wouldn't have to actually specify that it was a Boolean. It's also a compiled language, which is one of the reasons that it's so fast. So whenever you're writing Rust, you basically have to compile it to a binary specifically for whatever processor you plan on having it run on. So if you're writing an app and it needs to run on the new MacBooks, for example, you would need to compile it for the M1 processor. Same with if you're running it on Intel, you'd compile it for x86. So this means that distributing the software can be a little bit more challenging. So if you're going to build a CLI and put it on a repo where it can be pulled by lots of different chips or people using different chipsets, you would need to compile multiple versions of it so that it was always available. As I mentioned earlier, it does not have a garbage collector. So this means that you're responsible for freeing up memory after it's been used, which if you come from a JavaScript kind of background is a fair bit to get your head around. If you come from a lower level language background like C, this isn't actually all that bad. Basically what it means is when you create a variable, we assign some memory from the system to that variable. And then whenever you no longer need it, you're responsible for cleaning it up. But Rust does a really great job of helping us with this. It uses a system called memory ownership. And essentially, whenever a variable drops out of scope, it cleans its memory up itself. And this can be a little bit complicated if you want to pass a variable from one function to another, for example. But it uses a system called borrowing. So a function can borrow a variable, but the variable itself will still actually own the piece of memory. You can copy variables and stuff too. There's lots of ways around this sort of stuff, but by default, it's very quick and efficient just to keep these as borrowed variables. It's also got a cool mascot. This is Ferris. He features pretty heavily on the documentation and is used to kind of show code that's broken or code that's going to be particularly quick. And he uses his little pinchers and his happy face to tell you whether it's going to be good or bad. As with all things in technology, though, with the good, you get some bad. Rust compile time is not any fun. Because it's a compiled language, every time you make a change, you have to compile it to get it to run. So if you're working on something and you're trying to iterate quickly, this can be a bit of a pain in the ass. It's not too bad if you're just building like a simple little CLI, but if you're building a web framework that connects to databases and all kinds of stuff, and your code starts to get a little bit bigger, this can become a bit of a problem. It is getting faster though. There is a full section of the core team working to make the compile time as quick as possible. And they do have like a watch mode and stuff too. So it's able to recompile on every save. Got a pretty steep learning curve. As I said, you're responsible for memory management and all that kind of stuff. So if you're coming from a higher level language, you're probably going to have a bad time initially. But as you've seen from the slide earlier, once you sort of get over that, that trough of despair, people seem to love the language. I'm still in that trough of despair myself. So doing simple things is reasonably simple, but once you start doing anything a little bit more complicated, you start to run into the limits of your knowledge. But the documentation is great, so it's not as bad as I'm making it out to be. It's also got a relatively small user base. So when it comes to using third-party packages and stuff, there aren't a huge number of them out there. The standard library is fantastic, and you can do a lot with it. And it does have a package manager similar to NPM. It's called Cargo. One of the cool things with it being a compiled language is that and each individual crate, which is what a package is called in Rust, can run its own version of the language. So as newer features are added to the language and there's breaking changes added to the language, the version of the language being used is actually specified on a package by package level, which is quite cool. Then, as I said before, we use the borrow checker, which is part of the compiler and the sort of tool set that helps make sure that you're managing memory safely. And whenever you get started, honestly, it's a bloodbath. Like everything that you do, you think it's going to be simple, and the borrow checker just yells at you. But it does that in order to prevent you from running into those kind of memory safety issues that Microsoft had discovered. So there's probably a few people asking this question right now. I thought this was BelfastJS. We've already learned about no code as well. And I too like to come along with some opinions that don't necessarily fit for a JavaScript talk. But I do think this is relevant for JavaScript developers. I'm going to tell you a few reasons why. So the first one is WebAssembly. So I'm not sure if you're familiar with WebAssembly, but it's essentially a way to run code written in basically any language in the browser. And that code runs at basically native speed because it's compiled to like a byte code format. Rust is really well suited for WebAssembly because it doesn't have a garbage collector. Whenever you compile an app written in Rust to WebAssembly, you don't have to ship a garbage collector and the whole standard library along with it. Basically, you're the one responsible for managing memory. So you do that in your code, which you don't honestly really need to do a whole lot of. So it means it's very, very small, keeps your bundle size nice and small too. And there's a part of the core team whose job it is to make Rust the best language for writing WebAssembly in. Now, WebAssembly has pretty good browser support at this point. If you're using modern browsers, you can use WebAssembly. And you would want to use it if you had a feature in your app or something you were doing in the browser that JavaScript wasn't well suited for. So if you're running into performance issues or that kind of thing, and you wanted to offload some of that work to a worker, you can do it with WebAssembly and write it in whatever language you like, basically. But probably the most compelling reason I think that you should learn Rust and be aware of Rust is for the JavaScript tooling. Now, I don't really have a fancy slide for this, and honestly, this is mostly just opinion. But this is where I think Rust is going to take over the JavaScript landscape. Over the past decade, there's been a huge ecosystem built around JavaScript. So if you were compiling your code and you wanted to use multiple files, you would use Webpack. If you were converting your code to make sure it run on older browsers, you would use Babel. If you wanted to minify it, you'd use Terser. You've got Prettier. There's ESLint. There's a whole ton of tools written to make our lives as JavaScript developers easier. And basically, up until now, they've almost all been written in JavaScript or TypeScript, which is a really good thing for openness, to make sure that people using those tools also know how to edit and modify those tools. But JavaScript does have performance limitations. It's single-threaded. It does use a garbage collector, meaning that you can't really optimize beyond what JavaScript allows you to do. So over the past sort of few years, there have been a bunch of tools coming to market and being made available that can absolutely destroy most of these JavaScript tools written in more compiled languages. There's basically a whole new generation of them coming along. One of the first ones, and one of the ones I'm sure you've probably seen buzz around on Twitter, is ESBuild, which was it was released in January of 2020, and it's written in Go. But it's able to do basically all of the things from the packages I just named there: Webpack, Babel, Terser, but it can do them up to 100 times faster, which is honestly game changing whenever it comes to fast iteration when you're writing JavaScript. And there are plenty of those as well written in Rust. So you might have heard of SWC, which is what Next.js uses internally for compiling all of their code. It's basically a bundler, a compiler, and a minifier. We've also got Rome, which you might have heard of recently. It was built by one of the same guys that worked on Babel initially. And he wrote basically this entire tool chain called Rome. It was a linter, compiler, bundler, test runner, and he wrote it in JavaScript. But once he got his API nailed down, decided that he knew how it was going to work, he converted it to Rust. And again, it runs up to 70 times faster than the JavaScript version of it. You've probably also heard of Dino, which is like a Node.js alternative, like a modern, secure version of it that can automatically run TypeScript. And it's written in Rust as well. It uses V8 under the hood, which is written in C++, but all of the bindings are written in Rust. And I think that's one of the main reasons that, like, over the next few years, Rust is going to become fairly important in the web. I'm not suggesting anyone runs it today and starts learning it, but I think having a look at the docs and getting an idea of what Rust looks like and being able to read it means that whenever it starts eating your JavaScript tools, you'll have half an idea of what's going on. If you're looking to learn Rust, here's a few of the resources that I'd recommend. They're basically the rustlang.org website is fantastic for this kind of stuff. There's also rustadventure.dev by a guy called Chris Biscardi. It's fairly expensive, but it teaches you how to build games and all kinds of stuff. It's a really good video course. So that's worth checking out. And if anyone has any questions about Rust, I'm a total noob, but I'll do my very best to answer them.
Awesome. Thank you very much, Paul.
Thank you.
Very, very, very interesting topic. So we had a couple of questions come through. I just need to scroll through this chat to find them again. Yeah, so do you think WASM will replace JS on the web?
I think it's a famous Kyle Simpson thing where he said always bet on JavaScript. And I think that's still definitely the case. I don't think WASM is going to replace JavaScript. I think it's going to supplement it. I think with WASM, it's going to be very, very great for the kind of things that JavaScript isn't great for, but we're still going to be writing JavaScript. I don't see that going anywhere anytime soon.
Yeah, I agree. Another one here thinking like, so from a fellow speaker, David, like, am I right in thinking that crypto blockchain dev is being done in Rust?
As far as I'm aware, there is a particular cryptocurrency called Solana that's written in Rust. I think it's fairly similar to Ethereum and that kind of stuff. And one of the benefits of Rust that it is like fairly efficient. Like there's a lot of like ethical concerns about cryptocurrency. Solana, as far as I'm aware, is one of the ones that does a proof of stake rather than proof of work. So it doesn't like basically burn trees to make money. It's more about a consensus kind of a mechanism. I'm speaking there. I don't really know a whole bunch about cryptocurrency, but that's my understanding of it.
I think you did cover this talk. Was another question can be like, so Rust is like a non-managed or non-memory managed language, kind of like a C# or a C, whatever. Coming from, and I kind of did touch on this when you're talking, coming from the JS world, like, were there like brick walls or things that you had to kind of relearn to like get out of that garbage collection, beautiful world that we're already in?
Yeah, there totally was. Like every variable in Rust is immutable by default. So you're not able to create a variable and then modify it later, unless you define the variable as immutable. And there's all kinds of weird rules about what you can and can't do with immutable or mutable variables. And like honestly, I built a little app where I could. It was a CLI tool. I don't have it running here, otherwise I would show it. But basically, you would type in your address, and it would give you the wind speed at your address. I was just doing stuff. It was for flying. I was like, I wonder if I can build a little project whilst learning to fly, and I chose to use Rust for it. And that is a very simple tool. It makes a single API request to a weather service and gives you the wind speed back again. And I had a hard time. That was the first thing I built basically, and I was constantly having to like reference the documentation, like basically taking some data and mapping over it, which is nice and simple in JavaScript. It was really challenging because whenever I passed that data into a map, the map then took ownership of that data. And I was responsible for making sure that whenever I was finished with that data, that I was able to clear the memory up again. It's kind of hard to explain by talking about it. And the Rust book, honestly, is fantastic for explaining that kind of stuff. But for sure, it's a hard language to learn. And then one day it just kind of snaps and you're like, okay, I know how to do most of this stuff now. Most of my learning now is actually in the standard library, which is massive. So I've done stuff before. I'm like, okay, this is pretty hard to do. And then later on, I find there's a package in the standard library that does exactly what I spent 2 hours writing. Yeah,
so as well, like it gives me like horror flashbacks to my days of writing C and doing pointers and something broken and seg faulting the machine. Also, I want to see this code for this wind speed thing because I live up high and I always want to know like, are my bins going to like end up in the road if the wind's too high tonight? Then I need to strap them down. And kind of another one that came up was because like you're building in Rust, then Rust gets turned into JavaScript and that ends in the web. Like, what is the kind of like development, debugging experience working on that kind of thing? Like, do you get source maps? Do you get like a dev tools experience like you normally would?
Yeah, the Rust tooling is honestly fantastic, and I think that's one of the reasons that people love it so much. So I joked there that you're constantly going to be fighting the borrow checker, which is what is responsible for making sure that you are cleaning memory up correctly. But it's not so much fighting it. Like it is honestly super helpful. If you make a mistake, it'll give you like a little code snapshot of where that is in your code, what line it's on, the exact character that it's happening on, and then a link to the documentation that you might want to read, which will be useful to help solve the issue that you're having. And that experience is across Rust. It also has, like I said, it's really good for writing WebAssembly. So you can spin a project up as a WebAssembly project, and it'll spit out an npm module, which you can just import into JavaScript and it works right away.
Awesome. My question just came through there as well. Does compilation protect the source code?
Good question. I actually am not 100% sure. I would be very surprised if the likes of environment variables and that kind of stuff are fully safe. Like if you give someone code to run on their computer, whether it's compiled or not, they're probably going to be able to reverse engineer that in some way. So I wouldn't be including your AWS private keys and that kind of stuff in it. Someone that was very dedicated could probably reverse engineer that sort of stuff.
And then the last one, it's a question, but probably more of a statement. Like for myself, I don't know, maybe I'm getting too old and I'm like pushing against like the brand new things. was like, Webpack's awesome. Webpack's written in JavaScript. When Webpack doesn't work, I can, stick a debugger in the Webpack source. When if I'm now building my code with Rome, it's written in Rust. Am I losing that ability to, it's just JavaScript, I can debug it, or is it just like I'm an OFOE and I should get with the times?
No, I totally agree with you. I think that's a valid concern. I think there's a trade-off to be made. When everything is in JavaScript, we're able to push the language forward fairly quickly because the people writing JavaScript are also the people writing the tools. And that's great. And over the past sort of 10, 12 years, JavaScript has come on leaps and bounds. But I think now JavaScript is kind of starting to slow down and mature a little bit. And the language itself is changing less quickly. And I think that's now where people are starting to go, well, it's changing less quickly. Let's focus on working with it a lot nicer. And Rust and Go and stuff are pretty good for that sort of stuff. But you're right that whenever it breaks, if you don't know Rust or Go, you're probably going to have a bad time. But I would assume that the people writing these kinds of tools are writing them for JavaScript developers. I mean, that's what they're created for. They're JavaScript developers themselves mostly that have gone, we can do better than this. So I'm hopeful that those kinds of tools will be accessible for the layman that doesn't know Rust or Go.
Something else was very, very interesting. Like it's another thing added to my list of to learn. That's